get started. People will filter in as we go. But I want to talk a little bit about where this course has gone, and where hopefully I've pointed you towards the future. I sort of like to end this with these two perspectives, because we've seen as we've gone along, we've got a long history of science emerging, technology emerging from the scientific endeavor. It's led to our modern society. It's solved many of our long-standing issues. There are less people, percentage-wise, this percentage of the world population, less people in poverty today than ever before in human history. Now that's pretty astounding. Now that doesn't mean that there aren't still a lot of people in poverty and a lot of problems in the world, but we're addressing problems around the world with technology, water resources, food resources. The biggest problems now are distribution and politics. They're not the actual ability to feed people. There's enough food wasted every year to feed the world. So the solutions to our problems in many ways have been found. We've also generated new problems, right? Certain pollution, environmental impacts, things like climate change. We always have new issues as we develop more technology as well. So this is our pattern. The last few hundred years since the Enlightenment, we've solved problems, created problems, solved the problem, created a new problem. We've kept going. We have an expectation of medicine now that we've never had before in human history. But we have challenges in making sure that that is distributed equally and equitably. Challenges in our ethics, bioethics going forward, that everyone needs to participate in. So hopefully during the course of this course, you've been sort of dealing with or thinking about these two different perspectives. I sort of end with a big picture. This comes a little bit from a book that was written in the 1960s that was called Future Shock. We've talked about the science of the impossible. We've talked about bioethics and neo-evolution and all these really challenging ideas that may come about in the next few decades. And for previous generations, this was too fast, too much to adapt to. We look at my parents' generation and how much they struggle with computers and computing technology and things like that. Well, their parents, my grandparents, really struggled psychologically to deal with the pace of change. You guys are dealing with that because you're growing up with it. And it's almost to the point where we need to keep you awake and say, don't get too complacent. Yes, things are going to keep getting better. Your next iPhone is going to be able to do more than your last one. But there are also going to be additional challenges that everybody has to pay attention to. So we end with these two perspectives. 10 reasons to be worried about the future, and 10 reasons to be excited about the future. And I'm going to show you a video. I'm going to use the video by Sir Martin Rees to sort of talk about this, but also to tie it into the themes that we've been talking about throughout this class. And then afterwards, I'll talk a little bit more about the final. And I'm not going to go through all of these links. These are links in the textbook to the top 10 man-made disasters. I don't know why we like making top 10 lists, but we do as a culture. We like top 10 lists. There's nothing magical about the number 10. 20 ways the world could end. Again, you could make these any number of things. And the point is, we do have concerns either from our own actions or from natural disasters such as asteroid impacts, major volcanic eruptions. We could see in Yosemite, for instance, or in Yellowstone rather, or other parts of the world, the tsunamis and all the other natural disasters occurring near nuclear power plants. Well, that's a bit of a man-made one. The threat of nuclear annihilation, of terrorists getting nuclear weapons, things like that. Widespread disease, always a little bit worried about viruses getting out of control or being evolving that we can't deal with quickly and so forth. So there's all these fears and thrills that are being brought to us in the near future. But there's also a lot of very promising things that we've looked at And in a couple of the labs, I've had you look for these things, and we've talked about them and looked at them. And the coming singularity has been an issue that you may have kept up with. Ray Kurzweil's talk in lab last week, or 2 weeks ago, talking about basically the exponential rate of change and how we are approaching a time where our computer and the technology and the integration of our technology with our own biology is going to be both exciting and concerning. So I want to leave you with those two perspectives and make sure that the balance of healthy skepticism helps lead us forward into this exciting future, but with a wary eye. So let me let Sir Martin Rees expand on that idea.
If you take 10,000 people at random, 9,999 have something in common. Their interests and business lie on or near the Earth's surface. The odd one out is an astronomer, and I'm one of that strange breed. My talk will be in two parts. I'll talk first as an astronomer, and then as a worried member of the human race. But let's start off by remembering that Darwin showed how we're the outcome of 4 billion years of evolution. And what we try to do in astronomy and cosmology is to go back before Darwin's simple beginning, to set our Earth in a cosmic context. And let me just run through a few slides. This was the impact that happened last week on the comet. If they'd sent a nuke, it would have been rather more spectacular than what actually happened last Monday. So that's another project for NASA. That's Mars from the European Mars Express. And at New Year, this artist's impression turned into reality when a parachute landed on Titan, Saturn's giant moon. It landed on the surface. This is pictures taken on the way down. That looks like a coastline. It is indeed, but the ocean is liquid methane, the temperature minus 170 degrees centigrade. If we go beyond our solar system, we've learned that the stars aren't just twinkling points of light. Each one is like a sun with a retinue of planets orbiting around it. And we can see places where stars are forming, like the Eagle Nebula. We see stars dying. In 6 billion years, the sun will look like that. And some stars die spectacularly in a supernova explosion, leaving remnants like that. On a still bigger scale, we see entire galaxies of stars, with entire ecosystems where gas is being recycled. And to the cosmologist, these galaxies are just the atoms, as it were, of the large-scale universe. This picture shows a patch of sky so small that it would take about 100 patches like it to cover the full moon in the sky. Through a small telescope, this would look quite blank, but you see here hundreds of little faint smudges. Each is a galaxy, fully like ours or Andromeda, which looks so small and faint because its light has taken 10 billion light years to get to us. The stars in those galaxies probably don't have planets around them. The scant chance of life there, that's because there's been no time for the nuclear fusion in stars to make silicon and carbon and iron the building blocks of planets and of life. We believe that all of this emerged from a Big Bang, a hot, dense state. So how did that amorphous Big Bang turn into our complex cosmos? I'm going to show you a movie simulation, 16 powers of 10 faster than real time, which shows a patch of the universe where the expansion is subtracted out. But you see, as time goes on, in gigayears at the bottom, you will see structures evolve as gravity feeds on small density irregularities and structures develop, and we'll end up after 13 billion years with something looking rather like our own universe. And we compare simulated universes like that. I'll show you a better simulation at the end of my talk with what we actually see in the sky. Well, we can trace things back to the earlier stages of the Big Bang, but we still don't know what banged and why it banged. That's a challenge for 21st century science. If my research group had a logo, it would be this picture here, Ouroboros, where you see the micro world on the left, the world of the quantum, and on the right, the large-scale universe of planets, stars, and galaxies. We know our universe is a unity. There are links between left and right. The everyday world is determined by atoms, how they stick together to make molecules. Stars are fueled by how the nuclei in those atoms react together, and as we've learned in the last few years, galaxies are held together by the gravitational pull of so-called dark matter, particles in huge swarms, far smaller even than atomic nuclei. But we'd like to know the synthesis symbolized at the very top. The micro-world of the quantum is understood. On the right-hand side, gravity holds sway. Einstein explained that. But the unfinished business for 21st century science is to link together cosmos and micro-world with a unified theory symbolized, as it were, gastronomically at the top of that picture. And until we have that synthesis, we won't be able to understand the very beginning of our universe. Because when our universe was itself the size of an atom, quantum effects could shake everything. And so we need a theory that unifies the very large and the very small, which we don't yet have. One idea, incidentally, and I have this hazard sign to say I'm going to speculate from now on, is that our Big Bang was not the only one. One idea is that our three-dimensional universe may be embedded in a higher dimensional space, just as you can imagine on these sheets of paper, you can imagine ants on one of them, thinking it's a two-dimensional universe, not being aware of another population of ants on the other. So there could be another universe just a millimetre away from ours. But we're not aware of it because that millimetre is measured in some fourth spatial dimension, and we're imprisoned in our three. And so we believe that there may be a lot more to physical reality than what we've normally called our universe, the aftermath of our Big Bang. And here's another picture. Bottom right depicts our universe within our horizon. There's a lot beyond that, but even that is just one bubble, as it were, in some vaster reality. Many people suspect that just as we've gone from believing in one solar system to zillions of solar systems, one galaxy to many galaxies, we have to go to many Big Bangs from one Big Bang. Perhaps these many Big Bangs displaying an immense variety of properties. Well, let's go back to this picture. There's one challenge symbolized at the top, but there's another challenge to science symbolized at the bottom. We want to not only synthesize the very large and the very small, but we want to understand the very complex. And the most complex things are ourselves. Midway between atoms and stars. We depend on stars to make the atoms we're made of. We depend on chemistry to determine our complex structure. We clearly have to be large compared to atoms, to have layer upon layer of complex structure. We clearly have to be small compared to stars and planets, otherwise we'd be crushed by gravity. But in fact, we are midway. It would take as many human bodies to make up the sun as there are atoms in each of us. The geometric mean of the mass of a proton and the mass of the sun is 50 kilograms, within a factor of 2 of the mass of each person here, or most of you anyway. The science of complexity is probably the greatest challenge of all, greater than that of the very small on the left and the very large on the right. And it's this science which is not only enlightening our understanding of the biological world, but also transforming our world faster than ever. And more than that, it's engendering new kinds of change. And I now move on to the second part of my talk. And the book, Our Final Century, was mentioned. If I was not a self-effacing Brit, I would mention the book myself, and I would add that it's available in paperback. And in America it was called Our Final Hour, because Americans like instant gratification. But my theme is that in this century, not only is science changing the world faster than ever, but in new and different ways. Targeted drugs, genetic modification, artificial intelligence, perhaps even implants into our brains, may change human beings themselves. And human beings, their physique and character, has not changed for thousands of years. It may change this century. It's new in our history. And the human impact on the global environment, greenhouse warming, mass extinctions and so forth, is unprecedented too. And so this makes this coming century a challenge. Bio and cyber technologies are environmentally benign in that they offer marvellous prospects while nonetheless reducing pressure on energy and resources. But they will have a dark side. In our interconnected world, novel technology could empower just one fanatic or some weirdo with the mindset of those who now design computer viruses to trigger some kind of disaster. Indeed, catastrophe could arise simply from technical misadventure, error rather than terror. And even a tiny probability of catastrophe is unacceptable when the downside could be of global consequence. In fact, some years ago, Bill Joy wrote an article expressing tremendous concern about robots taking us over, etc. I don't go along with all that, but it's interesting that he had a simple solution. It was what he called fine-grained relinquishment. He wanted to give up the dangerous kind of science and keep the good bits. Now that's absurdly naive for two reasons. First, any scientific discovery has benign consequences as well as dangerous ones. And also, when a scientist makes a discovery, he or she normally has no clue what the applications are going to be. And so what this means is that we have to accept the risks if we are going to enjoy the benefits of science. We have to accept that there will be hazards. And I think we have to go back to what happened in the post-war era, post-World War II, when the nuclear scientists who've been involved in making the atomic bomb, in many cases were concerned that they should do all they could to alert the world to the danger. And they were inspired not by the young Einstein, who did the great work in relativity, but by the old Einstein, the icon of poster and t-shirt, who failed in his scientific efforts to unify the physical laws. He was premature, but he was a moral compass inspiration to scientists who were concerned with arms control. And perhaps the greatest living person is someone I'm privileged to know, Joe Rotblat, equally untidy office there, as you can see. He's 96 years old, and he founded the Pugwash movement. He persuaded Einstein's his last act to sign the famous memorandum of Bertrand Russell, and he sets an example of the concerned scientist. And I think to harness science optimally, to choose which doors to open and which to leave closed, we need latter-day counterparts of people like Joseph Rotblat. We need not just campaigning physicists, but we need biologists, computer experts, and environmentalists as well. And I think academics and independent entrepreneurs have a special obligation because they have more freedom than those in government service or company employees subject to commercial pressure. I wrote my book, Our Final Century, as a scientist. Just a general scientist, but there's one respect, I think, in which being a cosmologist offered a special perspective. And that's it offers an awareness of the immense future. The stupendous time spans of the evolutionary past are now part of common culture, outside the American Bible Belt anyway. But most people, even those who are familiar with evolution, aren't mindful that even more time lies ahead. The sun has been shining for 4.5 billion years, but it'll be another 6 billion years before its fuel runs out. On that schematic picture, a sort of time-lapse picture, we're halfway. And it'll be another 6 billion before that happens, and any remaining life on Earth is vaporized. There's an unthinking tendency to imagine that humans will be there, experiencing the sun's demise. But any life and intelligence that exists then will be as different from us as we are from bacteria. The unfolding of intelligence and complexity still has immensely far to go here on Earth and probably far beyond. So we are still at the beginning of the emergence of complexity on our Earth and beyond. If you represent the Earth's lifetime by a single year, say from January when it was made to December, the 21st century would be a quarter of a second in June, a tiny fraction of the year. But even in this concertina cosmic perspective, our century is very, very special. The first when humans can change themselves and their home planet. As I should have shown this earlier, it will not be humans who witness the end point of the sun. It will be creatures as different from us as we are from bacteria. When Einstein died in 1955, one striking tribute to his global status was this cartoon by Herblock in the Washington Post. The plot reads, Albert Einstein lived here. And I'd like to end with a vignette, as it were, inspired by this image. We've been familiar for 40 years with this image, the fragile beauty of land, ocean and clouds, contrasted with the sterile moonscape on which the astronauts left their footprints. But let's suppose some aliens have been watching our pale blue dot in the cosmos from afar. Not just for 40 years, but for the entire 4.5 billion year history of our Earth. What would they have seen? Over nearly all that immense time, Earth's appearance would have changed very gradually. The only abrupt worldwide change would have been major asteroid impacts or volcanic supereruptions. Apart from those brief traumas, nothing happened suddenly. The continental land masses drifted around, ice cover waxed and waned, successions of new species emerged, evolved and became extinct. But in just a tiny sliver of the Earth's history, the last 1/1,000,000th part, 2,000 years, the patterns of vegetation altered much faster than before. This signaled the start of agriculture. Changes accelerated as human populations rose. Then other things happened even more abruptly. Within just 50 years, that's 1/100th of 1/1,000,000th of the Earth's age, the amount of carbon dioxide in the atmosphere started to rise enormously fast. The planet became an intense emitter of radio waves, the total output from all TV and cell phones and radar transmissions. And something else happened. Metallic objects, albeit very small ones, a few tons at most, escaped into orbit around the Earth. Some journeyed to the moons and planets. A race of advanced extraterrestrials, watching our solar system from afar, could confidently predict Earth's final doom in another 6 billion years. But could they have predicted this unprecedented spike less than halfway through the Earth's life? These human-induced alterations occupying overall less than a millionth of the elapsed lifetime and seemingly occurring with one-way speed. If they continued their vigil, what might these hypothetical aliens witness in the next 100 years? Will some spasm foreclose Earth's future, or will the biosphere stabilize? Or will some of the metallic objects launched from the Earth spawn new oases of post-human life elsewhere? The science done by the young Einstein will continue as long as our civilization, but for civilization to survive, you need the wisdom of the old Einstein, humane, global and far-seeing. And whatever happens in this uniquely crucial century will resonate into the remote future and perhaps far beyond the Earth as depicted here. Thank you very much.
Navy Yard is 300 acres on the Brooklyn waterfront. It was one of the most historic naval shipbuilding facilities. Some of our country's most famous ships were built here.
All right. I like showing that one. It really, in a lot of ways, is a perfect outline for the class. I mean, I didn't design the class that way, but I found the video. I've been showing it at the end. I could just as easily show it at the beginning as an introduction. Because he goes through everything. I mean, he talks about the Earth's history, he talks about the history of the cosmos, the beginnings of the cosmos. He talked about our own efforts historically to produce our modern society and so forth. And then he thinks about going forward and what the challenges might be. And again, that's where I want to kind of leave things with you. Most of you filtered in during that. Probably didn't get the full impact of it. If you watch it again before the final exam, maybe you will have a better perspective coming into the final exam. Because what I want you to understand is the final exam is not multiple choice. It's not going to ask you to repeat information that you've learned during this class. It's going to ask for your perspective. It's going to ask for you to watch a video and tell me, what you take from it. Keep in mind from the first 3 exams that those are graded by your engagement with those questions, not by the specific information that you give me. Okay, I want to see that you are thinking about these issues and coming up with a personal philosophy or approach to these things that, if it has not changed your life, at least helped you focus your thoughts or thinking on these issues. Okay? So I need to see something in your thinking that's related to these topics. And you can expect topics that cover the range of things that we've talked about in class. There will be, for instance, perhaps videos about the earth and the environment, videos about our own biology and bioethics, videos perhaps about physics and chemistry in a cosmic perspective. So they're more of a synthesis than they are like breaking it down into sections and saying, okay, here's a question about this section, here's a question about that section. But there will be perspectives from every section of the course that we've covered. Okay, does that make sense? Yes?
Sorry, this might be a stupid question, but you said we're going to watch videos for the...
Yes.
So is it going to be here?
That's what I was just about to say. There are a couple of there's going to be 10 questions, and the way it's shown on the test, it will say Station 1, Station 2. And the reason for that is that some of these are what are called lab practical type questions. They'll be done in a specific location. So South 806 is where I will have some of those stations set up. Maybe 3 or 4 of the 10 will be in there. The rest of them can be done anywhere, so any computer lab. What I want to encourage you to do is, not all of you try to do those stations that are in the classroom at the same time, because not everyone can fit in there at the same time, okay? You come in, get the test, go to a computer lab, evaluate the test, right, get started on it, come back and do the things that are in the classroom during the course of the time that you have. Some of you will stay and do them pretty early, some will do those at the end, somewhere in the middle, whatever. But most of the exam can be done anywhere on campus. It's completely open book. All the questions are open book. Any resource you want, get on the computer, whatever. Just don't copy each other's answers. Now this is a sticking point, because obviously I'm letting you go, right? I'm not going to follow you around and make sure you're not sharing information. But if I get the same answers, which inevitably I do occasionally get the same answers, I'm not going to count them. They're not going to count. I need to see your thinking, your opinions. If you talk to somebody about an issue to help develop your thinking, okay, but don't just say, what did you say, and write that down, okay? You have to come up with your own thoughts. It has to be your own thinking. So if I see the same answers on 2 exams, they'll both be discarded. You understand? And this is 200 points out of the 1,000. Yes?
Is this the video that we just saw? Was it, where was it? I know it's up.
It's in the book here. There's a link to it.
Future shot.
Is this our final century? This link up here.
Okay.
And it's a TED.com talk. I think it's also the last discussion board topic. That's the other thing. Keep in mind, all the discussion board topics should be done really by tomorrow. Okay, technically by the end of this week at the latest, because this is the last week of the class. We don't have lab this week because we only have today. Thursday is a reading day. Okay, but you should have all of the discussion board topics done by the end of this week. So hopefully all of you have been keeping up with them. If some of you are hearing this and going, what discussion board? That's not good. We talked about them at the very beginning. It's in the syllabus. There's links to the topic in the book. It seems difficult for you to have missed the fact that there's a discussion board, but inevitably there's 3 or 4 people in the class who have not done any of the discussion board topics. When I go in to grade them and I go, oh my goodness, this person, based on their grades on the test, could have made a B. but because they didn't do any discussion and they only came to half the labs, I'm going to have to give them a D. I pointed this out at the beginning, and I want to make it perfectly clear again. Half of the points for this course come from participation, half come from tests. You have 300-point exams, one 200-point final exam. That's 500 out of 1,000 points that are available for you in this course. 500 of the points come from the discussion board, coming to lab, participating in lab activities and discussions, and doing things, along the way. All right, so I don't know what it is about, and again, my son's the same, same way. So it's not, it's something about psychology, young adult psychology. But if you come in thinking, I just have to do okay on the tests, you're going to fail the class if you're not coming to lab. Now, it's too late to start coming to labs. We don't have any more labs. But what I'm talking to is any of you who may have not done the discussion board. You need to do it because you can't afford to lose that point. If you've got 1,000 points and you just ignore 100 of them, you'd have to be perfect in everything else to get an A. So you're not, essentially, you've thrown that letter grade out the window by not doing the discussion. Does that make sense? All right. And again, I'm saying this just, I don't know, maybe one or maybe no one, but there always seems to be somebody in this course when I go in to grade everything that just didn't do the discussion board. And it's a shame because every once in a while it's somebody who otherwise did pretty well, but that cost them a letter grade. Yes?
Is there any way that we'll be able to find out where we stand as far as our grade as by the end of this week?
Well, again, the quiz average is available in the book, right? You're just, and I know this is somewhat difficult because I don't have it recorded anywhere for you, but if you've been coming to lab, right, that's 200 points. You can count that as 200s, essentially. If you've been doing the discussion board, as long as you've been doing a reasonable job on that, that's 100 points. Okay, so you've got the quizzes, the 200 points of the lab, the 100 points for the discussion board, that's your 400 points. You've got, what you made on the first two exams. I'll have the grades for this one. Maybe you can, if you want to email me about it before the final. But take your two exam grades, your quiz average, and if you've been coming to lab, add 300 points to that, divide by 6, and see what your average is. Okay? Yes?
On that grade level in our quizzes, are the discussions included in there?
No.
No, not yet? Okay.
No. No, those are just quiz grades, yes.
Do you also base the discussion boards on what we reply to people or just what we post?
I am going to go in and look at your comments and make sure that they are engaged, not just yes, me too, or I agree, or something quick like that. Other than that, I'm not going to grade your responses in terms of whether I agree with you or whether you agree with each other or anything like that. It's about being engaged with it. Okay, so if you've gone in and given me a good comment, you're going to get 100 on
No,
that.
I mean like when we reply to other people's,
If you've added additional, you're required to do one comment per thread. If you put additional comments in there, then you get extra credit for that. All right, yes?
Can we bring our laptops for the final?
Yes. Yeah, you can bring your laptops, you can bring notebooks, again, you can bring anything. One of the reasons for this, again, I'm not trying to test you on your knowledge. If you're trying to remember something that we talked about in order to connect to a video or something like that, to draw upon that knowledge, I want you to have that available. I don't want you to be struggling to find it. Okay, this course is not about memorizing things. It's about becoming engaged and taking that with you as a healthy skeptic going forward, because and I know it may sound silly, but society needs you to be aware of these issues and to be engaged with these issues going forward throughout the rest of your life. I mean, we all need to be engaged with these things. You all have to be scientists, but you all are voters and you're all consumers and you all matter, and your opinions matter and they need to be heard. So they need to be informed decisions and opinions, but I'm not here to judge your opinions. Just how engaged you are with them. Yes.
Dr. Hope, after the completion of this test, will we have to bring it back to you somehow? Or
Yeah, you'll bring it back to South 806 and leave it with me at the end.
Okay, after
Yeah,
we finish.
right.
How long do we have?
You get about 3 hours.
3 hours. Okay.
I mean, it's 2 hours and 45 minutes from 8:30 to 11:45 or whatever, but you know,
On what day is it?
it's the 8th. It's a week from today,
South,
or 9th, right, sorry, 9th.
South what?
South 806, where we have lab. Now, if you were in Monday's lab, you aren't coming to South 806, but come to South 806 for the exam. That just occurred to me, so yeah, thank you for that. The Monday's lab has been meeting in the Student Research Resource Center, the Natural Sciences SRC, but for the exam, come to South 806, all lab sections. Yes?
You said the final is the 8th, Monday?
No, it's the 9th. I'm sorry.
Okay.
It's a week from today. I don't had it in my mind as the 8th. Yes?
So do we come in for the day?
No, we're not going to meet for reading day because there's no need to. Reading days are a resource for you. Of course, the courses we're not allowed to make any assignments for reading day. What it's good for is to catch up. If you need to catch up with some of the discussion board topics, that's what reading days are for. And that's, you have till the end of this week to do that. But we aren't going to meet as a group on Thursday. And we're not going to meet for lab this week because we only have one day this week. So again, labs are done. We're done with labs. Are there any other questions about the final exam? Yes. How many points? Oh, 10 questions. Again, there's going to be a couple of them that are interactive, like maybe the periodic table. Okay? It's not going to be hard. It's going to be like a scavenger hunt or something. Like, fill in this table. I don't know if I'm going to use that question or not. It's a question I've used before in the past. It could be a cartoon. Explain why this cartoon is funny. Again, like I've done on the bonus questions. It could be a video or an article. Watch this video and discuss the issues that this video gives. It could be those, remember in lab when we talked about those physics problems that are sort of multiple choice, but they're those cartoon-like problems that pose a question like whether you put the cream in your coffee right away or you wait, right?
That was on the last.
That was on the last test, and in fact, there won't be anything in that we haven't either had on a previous test or talked about in lab specifically. I may ask you to take one of those, if there's 5 of those, in one station, and explain in the next one. So that one will draw upon some of your notes, for instance. But those are the kinds of things that'll be on there, and again, there's going to be 10 questions. And I'm not sure exactly yet. I sort of have a pool of things that I pull together for these final exams, different videos. I mix them up around. There's a new one I saw recently that I know I'm going to include. And you can also expect something about the perspective of all of this, like we just did today with Sir Martin Rees's presentation, putting it all into a context, in a societal context. He talked about the concerned scientists and the role that scientists have in providing information to the public so that you can make the decisions that need to be made. When we practiced that with the climate summit, we looked at the science behind it and then had a public debate about it. The science is not a debate. Science doesn't proceed by debate, but the information that science provides is available for political discussion, political debate, and so on. And needs to be, because we are dealing with the issues that we created, as he said, with everything good. There are challenges, and we need to be prepared for those going forward. We need to be particularly prepared in this coming century, because some of the new technologies that are going to, again, help cure diseases and feed the hungry and provide energy and on, are also going to have ethical concerns with our own biology and our own health and the distribution of wealth in our society and so on. So that's why I'm trying to leave you with this kind of perspective, but with a healthy skepticism to face it going forward. Okay, because all of us, even old-timers like me, have plenty of time left to see these things happening and to participate in the discussions that are necessary going forward. All right, anybody else have any questions about the final exam? Bring headphones. I just recommend that. You can bring your own laptop, whatever you want, but I do recommend you bring some headphones, because if you're watching a video in the computer lab, they're not going to, want you to have the volume turned up, and they don't provide their headphones in the computer labs. It's just cost prohibitive. So bring some headphones. Most of you have them, earbuds, whatever. I mean, most people have them anyway, but I'm just saying that make sure you have some. All right, also make sure you leave your exam 3 take-home portion on the table on your way out. And I will see everybody Tuesday morning in South 806.